Hey there, I'm Jeremy Howard, President and Chief Scientist of Kaggle, and obviously totally out of my depth here, but at least this sound system makes me sound so masculine, so that feels good. So I'm talking about machine learning today, and we all know that machine learning is everywhere now. It powers, in fact, it's maybe the strategic backbone of so many commercial scientific opportunities around the world. Yet somehow there's a big problem, which is everybody you talk to, CEOs, CIOs, who have lots of data, they all say the same thing. I've got all this data, but I don't know how to turn it into value. I don't know how to turn it into insight. And yet you talk to researchers, and they all say something else, which is, we've got all these great ideas for algorithms, but we can't find any real-world data. We can't find any real-world problems to apply it to. So clearly there's an amazing mismatch going on here, something really strange. So we built a company called Kaggle, which uses a crowdsourcing approach to bring these two parts together. In fact, it's a very specific kind of crowdsourcing approach. It's based around the concept of the competition. Yes, machine learning competitions. Here's a snapshot of our webpage as it was a couple of days ago, showing a few of our competitions, ranging up to a $3 million prize if you can figure out how to identify who is most at risk of hospitalization, also including things like the Microsoft Kinect Gesture Recognition Challenge, if you can come up with a one-shot gesture recognizer. The heart of Kaggle, which makes it so powerful, is this. It's the RealTime Leaderboard. Every single Kaggle competition is a predictive modeling competition which can be scored in real time. You can put up a new solution every day, and you can find out every day exactly where you sit on the real-time leaderboard. And you can watch yourself go up and down as you get better and other people get better and they surpass you and so forth. So it really harnesses that competitive instinct we all have. The way this works is that the predictive models are scored on actual past data which the competitors are not told about. So a couple of years ago, we tried this out for the first time. We put up a competition. And within moments, thousands of people from all over the world started entering. The competition was about predicting HIV viral load. Who is most at risk of HIV progressing? For 4 years, researchers have worked on this problem using genetic markers, and it achieved an accuracy of 70%. We were blown away to find that within a week and a half, this new platform had found an even better answer. At the end of the competition, 3 months later, 77% was the new benchmark that had been set. This was truly exciting. And so therefore, a year later, when this group of amazing institutions came to us with their own problem, we were really excited about what we could do. The problem they came to us was mapping dark matter. How can we use distant galaxy images and see how they are slightly warped by the gravity of dark matter to actually map the dark matter in the universe? A great idea, but nobody had come up with a sophisticated enough algorithm. So what we did was we put it up on Kaggle for these guys. And here's what appeared on the White House website within 2 weeks. A PhD student in glaciology surpassed all state-of-the-art algorithms. And in fact, within 3 months, NASA's best algorithm had been beaten by 300%. Now there's been over 100 Kaggle competitions. In every case, the world's best practice has been surpassed. For example, Allstate's actuarial algorithms, the heart of their business, improved by 340% in 3 months. How is this happening? Because there are over 32,000 data scientists competing on Kaggle from all over the world, from research institutions, from companies. Many of the world's best predictive modelers today compete against each other on the site, bringing a wealth of approaches to a wealth of problems from many different backgrounds and applying many different techniques. The other thing that happens is that over time, and here the x-axis is time for a competition, the error rate on a competition, and this is one example from a few months ago, improves and improves and improves as people keep passing each other. In this competition, I was the guy that actually made the first big breakthrough. A few weeks later, I was suddenly 5th. My ego was hurt enough that it pushed me to try again and ended up winning. For private data sets, we can even do that. We invite 10 of the world's best data scientists to secretly compete on private data sets with sensitive IP, and we call these things private competitions. If you'd like to know more, I'd love for you to contact me because I'd love to hear about how we might be able to apply this in the world of engineering. Thank you.